Good day. Can you see the boat? Do you see?
Yes.
Okay. We begin our new semester with the theme line integrals and surface integral. It is a new big theme. Take your copybooks, take your pens and begin. Line integrals. And surface integral. And start with line integrals. Now let's plot the Cartesian coordinate system, y-axis, x-axis, and on this system plot any curve L. This curve. Let point P be in motion along the same plane line L from the point M to the point N. To be applied a force F which varies in magnitude and direction with the motion of P. It is thus some function of the coordinate of P. F is f of P. Let us compute the work A of the force F, as the point P is translated from M to N. To do this, we divide the curve MN into n arbitrary parts by the point M0 is M, then M first, M second, etc. to here M i's, this maybe M I plus first, etc. to mn's that equal to n, in the direction from m to n, and we denote by delta s i's the vector from mi's to mi plus first. We denote by f i's the magnitude of the force F at the point mi's. Then the scalar product Fi's times delta Si's may be regarded as an approximate expression of the work of the force F along the arc mi's to mi plus first. A i's approximate equal to F i's times delta S I, scalar product. Let F equals x of x y times I plus y of x y times g, where I and g is coordinate odds and x and y is coordinate of the first force F. It means x of xy and y of xy are the projections of the vector F on the x and y axis, denoted by delta x i's and delta y i's. The increments of the coordinates x, y, and y i's when changing from the point mi's to the point mi plus first. It means here x i's in this x I plus first that equals x i's plus delta x i's. Same way, y i's y I plus first equals y i's plus delta y i's. Here delta y i's in this delta x i's distance. We get delta S i's equals delta x i's times I plus delta y i's times G. Hence, the scalar product f i's times delta s i's equals capital X of x i's y i's times delta x i's plus capital Y of x i's y i's times delta y i's. The approximate values of the work A of the force F over the entire curve MN will be A approximate equal sum over I from 1 to n of scalar product f i's times delta s i's or sum over I from 1 to n of x i's y i's times delta x i's plus y of x i's y i's times delta y i's. Formula 1. Without making any precise statements, we shall say that if there exists a limit of the expression of the right as delta s i's approaches 0, here obviously delta x i's and delta y i's approach 0 both of these. Then this limit expresses the work of the force F over the curve L from the point M to the point N. It means the work A equals limit as delta x i's approaches 0 and delta y i's approaches 0 too, of sum over I from 1 to n of x i's y i's times delta x i's plus y of x i's y i's times delta y i's. Formula 2. The limit on the right is called the line integral of xy and y of xy. Over the curve L and is denoted by A equals line integral over L of x y dx plus y of x y dy. Formula 3. Or A equals integral from the point M to the point N of x y dx plus y of x y dy. Formula 3 prime. Limits of sums of type 2 frequently occur in mathematics and mechanics. Here x of x, y and y of x, y are regarded as function of two variables in some region D. The letter m and n, which take the place of the limits of integration, are in brackets to signify that they are not numbers but symbols of the end point of the line over which the line integral is taken. The direction of the curve L from M to N is called the sense of integration. Write down this. The direction of the curve L from M to N is called the sense of integration. If the curve L is a space curve, then the line integral of three functions x of x, y, z, y of x, y, z, and z of x, y, z is defined similarly integral over L of x, y, z dx plus y of x, y, z dy plus z of x, y, z dz equal to limit as delta x case approaches 0, delta y case approaches 0, delta z case approaches 0 of sum over k from 1 to n of x case, y case, z case, delta x case plus y of x case, y case, z case, delta y case plus z of x case, y case, z case, delta z case. The letter L under the integral sign indicated that the integration is performed along the curve L. We note two properties of a line integral. Property 1. A line integral is determined by the element of integration, the form of the curve integration, and the sense of integration. a line integral is determined by the element of integration. The form of the curve of integration. And the sense of integration. A line integral changes sign when the sense of integration is reversed. Since in that case the vector delta s and hence its projection delta x and delta y changes sign. Property second. I'm sorry. Divide the curve L by the point K into pieces L first and L second. Here point. So that MNs equals MKs plus KNs this curve N N K L first L second. Then from Formula 1, It follows directly that integral from m to n of x dx plus y dy equals integral of m to k of x dx plus y dy plus integral from k to l and so on. X dx plus y dy. This relationship holds for any number of terms. It will further be noted that the definition of a line integral holds true also for the case when the curve L is closed. In this case, the initial and terminal points of the curve coincide. Therefore, in the case of a closed curve, we cannot write integral from m to n x dx plus y dy, but only integral over L x dx plus y dy. And we have to indicate the direction of circulation, sense of description over the closed curve L. The line integral over a closed contour L is frequently denoted also by symbol integral over a closed contour L of x dx plus y dy. We arrived at the concept of a line integral while considering the problem of the work of a force F on a curved path L. Here at all points of the curve L, the force F was given as a vector function F of the coordinates of the point of implication with coordinate x, y. The projection of the variable vector F of the coordinate x's are equal to the scalar numerical, that is function x of xy and y of xy. For this reason, the line integral of the form integral over L of x dx plus y dy may be regarded as an integral of the vector function f given the projection x and y. The integral of a vector function f over the curve L is denoted by the symbol integral over L of f ds. If the vector f is defined by its projection x, y, z, then this integral is equal to the line integral integral over L of x dx plus y dy plus z dz. As a particular instance, if the vector f lies in the xy plane, then the integral of this vector is equal to integral over L of x dx plus y dy. When the line integral of a vector function f is taken along a closed curve L, this line integral is also called a circulation of the vector f over the closed contour L. Circulation. Here L. Circulation. Now I give you the screenshot of this board in the chat. One minute, please. Clean this board. Так, now I will check you. Group 2202. Abazer Saldin Bashir Salih not. Abel Sud Abdurrahman Ahmed Fahmi. Abel Sud not. Abulela here. Here Abulela, yes. Ali Abdallah Mohammed Khalil. Ali Abdallah not. Ali Ahmed Mohammed Ali. Ali Ahmed Mohammed Ali not. Al-Hasnavi Hussein Amir Musa.
Yes, I'm here.
Here. Al-Furaiji Yusuf Amagatea. Here.
Yes.
Ata Mohammed Al-Said Mahmoud Mohammed. Ata Mohammed not. Badri Abdurrahman Ali Hagak. Here. Bin Said Ramzi Rauf. Here. Bin Jadesrey Hussein Saad Sachit. Here. Garasmin Makram Riyad. Here. Grace Bishoy Adel Mikhail not. Gusay Kamal not. Janine Ayub here. Yepes Banilia Brian Fernanda here. Loa Awad Suleiman Ibrahim not. Mohammed Tariq Faraout here. Adel Jefferson Sabiti not. Amer Gamalaldin Hussein Yedris not. Atman Tariq Khalid Klika here. Fuad Mohammed Taha not. Haider Diyar Malik Haider not. Hassan Assama. Haysam Rizk Mohammed not. Hussein Hassan Ahmed Aliyev here. Yahya Faisal Hassan Yusuf not. I save. And another group 2204.
Doctor,
Yes.
Abulela Saad, can you check me?
Who?
Abulela Saad.
Repeat please, I don't understand.
Abulela Saad.
Abulela, yes. Yes, I check it.
Okay.
Group 4. Abderrahim, not. Alabaidi Mahanat Abdurakim. Alabaidi here.
Right here.
Alabaidi here. Ali Mahmud Marwan Mahmud Ginidi. Not. Alami Hussein. Alami Hussein. Not. Al-Salim Musab Mayat Hamid. Here.
Yes, here.
Dirakarim Ali Mahmud. Not. Ilnuvihi. Not. Zabar Abdurrahman. Not. Mansur Mohammed Ibrahim Rabi. Not. Sultan Amar. Not. Elgendi here.
Yes.
Okay. Very good. It means now you have 5-minute rest and then we continue. Now 5-minute rest. Okay?
Okay.
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 5-minute rest. After 5 minutes we continue. Continue. Are you here?
Yes.
Okay. Our next subtitle, Evaluating a Line Integral. Evaluating a line integral. In this section, we shall make more precise the concept of the limit of the sum. First, it is, I repeat it, A approaches equals sum over I from 1 to n of scalar product f i's times delta s i's that equal to sum over I from 1 to n of x of x i's y i's delta x i's plus y of x i's y i's delta y i's and in this connection we shall make more precise the concept of the line integral and indicate a method for calculating it. Let a curve L be represented by equation in parametric form. X is phi of t and y is psi of t. Consider the arc of the curve MN as on the figure. Let the point M and N correspond the values of the parameter alpha and beta. Divide the arc MN into subarc delta SI's. By the point M first, with coordinate x first, y first, M second with coordinate x second, y second, etc. to M case with coordinate x case, y case, to M n's that equal to n. put xi's equals phi of ti's. Yi's equals psi of ti's. Consider the line integral over L of x xi dx plus y of xi dy, formula 1, defined in the preceding section. We give without proof the existence theorem of a line integral. Existence theorem of a line integral. If the function phi of t and psi of t are continuous and have continuous derivative phi prime of t and psi prime of t, and also continuous are the function x of phi of t psi of t and y of phi of t psi of t as function of t on the interval from alpha to beta, then the following limits exists. as delta xi's approaches 0 of sum over I from 1 to n of x of xi's with the upper line, yi's with the upper line, delta xi's equals integral of x's dx, and limit as delta xi's approaches 0 of y of sum over I from 1 to n of y of xi's with the upper line and yi's with the upper line, delta yi's equals integral of y of xi's xy dy. Almost 2, where xi's with the upper line and yi's with the upper line are the coordinates of some points lying on the arc delta SIs. These limits do not depend on where the arc L is divided into subarc delta SI. Provided that delta SIs approaches 0. And do not depend on the choice of the point. MIs with the upper line with the coordinates XIs with the upper line and YIs with the upper line on the subarc delta SIs. They are called line integrals. and are denoted as limit as delta xi approaches 0 of sum over I from 1 to n of x's with the upper line yi's with the upper line delta xi's equals integral over L of x y dx and limit as delta yi's approaches 0 of sum over I from 1 to n of y of xi's with the upper line yi's with the upper line delta yi's equals integral over L of y of xy dy. From this theorem, it follows that the sums defined in the preceding section, where the point M, Y with the upper line with the coordinate xi's of and yi's with the upper lines are the extremities of the subarc delta si's and the manner of partition of the arc L into subarc delta si's in arbitrary approach the same limit the line integral. The theorem makes it possible to develop a method of computing a line integral. Thus, by definition, we have integral from m to n of x y dx equals limit as delta xi's of sum over I from 1 to n of x's with the upper line yi's with the upper line delta xi's, formula 3, where delta xi's equals xi's minus xi minus first equals f of ti's minus phi of ti minus first. Transform this latter difference by the Lagrange formula. Delta xi's equals phi of ti's minus phi of ti minus first equals phi prime of theta i's times ti's minus ti minus first equals phi prime of theta i's times delta ti's, where theta i's is some value of t that lies between the values ti minus first and ti's. Since the point x i's with the upper line, y i's with the upper line on the subarc delta s i's may be chosen at presse, we shall choose it so that its coordinates correspond to the value of the parameter theta i's. X i's with the upper line equals phi of theta i's, and y i's with the upper line equals psi of theta i's. Substituting into tree the values of x i's with the upper line, y i's with the upper line, and delta x i's that we have found, we get integral from m to n of xy dx equals limit as delta t i's approaches 0 of sum over I from 1 to n of x of psi of ci's это xi of ci's phi prime of ci's theta i's, sorry, theta i's, delta ci's. On this right is the limit of the integral sum for the continuous function of a single variable x of phi of t, psi of t, phi prime of t on the interval from alpha to beta. Hence, this limit is equal to the definite integral of this function. Integral from m to n of x y dx equals integral from alpha to beta of x of phi of t, psi of t of times phi prime of t dt. In analogous fashion, we get the formula integral from m to n of y of xy dy equals integral from alpha to beta of y of phi of t, psi of t times psi prime of t dt. And in this equation, term by term, we obtain that integral from m to n of y dx plus y of y dy will be equal to integral from alpha to beta of x of phi of t, psi of t plus y of phi of t, psi of t I'm sorry. Алло? Алло? Алло. Светлана, у меня лекция идет. У меня идет лекция сейчас. Вы понимаете, что у меня сейчас ждут 150 человек вашего предложения? Я на лекции нахожусь. I'm sorry. What is it? Here. C prime of C. Don't want to write. Here I forgot phi prime of C, phi prime of C. dt. This is the third formula for computing a line integral. In similar manner, we compute the line integral of x dx plus y dy plus z dz over the space curve defined by the equation x is phi of t, y is psi of t, and z is phi of t. Consider the example. Compute the line integral of three functions x cubed, 3z y squared, and minus x squared y, or which is the same thing, or the vector function x cubed times I plus 3z y squared times g minus x squared times y times k. Along a segment of straight line reaching from the point M with the coordinate 3, 2, 1 to the point N with the coordinate 0, 0, 0. Solution. To find the parametric equation of the line ML along which the integration is to be performed, we write the equation of the straight line that passes through the given two-point x over 3 equals y over 2 equals z over 1. And denote all these relations by a single letter t. Then we get the equations of the straight line in parametric form. X is 3t, y is 2t, and z is t. Here, obviously, to the origin of the segment MN corresponds the value of the parameter t is 1, and so the terminus of the segment, the value t is 0. The derivatives of x, y, z with respect to the parameter t which will be needed for evaluating the line integral are easily found. X prime over t equals 3, y prime over t equals 2, and z prime over t equals 1. Now the third line integral may be computed by formula 4. Integral from m to n of x cubed dx plus 3z y squared dy plus x squared y dz equals integral from 1 to 0, t is 1 to t is 0, of x cubed 3t cubed. Then x prime over t, 3, plus 3, then z t, then y squared, y is 2t, 2t squared, dy, y prime, 2, plus x squared, 3t squared, then y, 2t, dz, 1. With respect to t, dt over t equals integral from 1 to 0, 87t cubed dt equals 87 minus 87 over 4. Next example, example 2. Evaluate the line integral of a part of function 6x squared y 10 xy squared along a line curve y is x cubed from the point M with the coordinate 1, 1 to the point N with the coordinates 2, 8. This graph. Solution. To compute the required integral from M to N, 6x squared y dx plus 10x y squared dy. We must have the parametric equation of the given curve. However, the explicitly defined equation of the curve y is x cubed is a special case of the parametric equation. Here, the abscissa x of the point of the curve serves as the parameter, and the parametric equation of the curve are x is x and y is x cubed. The parameter x varies from 1 to 2. The derivative with respect to the parameter are readily evaluated. X prime with respect to x equals 1 and y prime with respect to x it is 1, number 1. Y prime with respect to x equals 3x squared. Okay. Hence, our integral equals integral from 1 to 2 of 6x squared x cubed times 1. It means y is x cubed, x squared x cubed, plus 10x times y squared x to the power of 6 times y prime of x 3x squared or x equals integral from 0 to 1, from 1 to 2, sorry, of 6x to the power of 5 plus 13 x to the power of 9 dx equals x to the power of 6 plus 3 x to the power of 10 from 1 to 2. And after calculation, we will have 1084. We now indicate certain implication of a line integral. The expression of the area of a region bounded by a curve in terms of a line integral. In an xy plane, let there be given a region D bounded by the contour L, such that any straight line parallel to one of the coordinate axes and passing through an interior point of the region cuts the boundary L of the region in no more than 2 points, which means that region D is regular. Now maybe I give you the picture. Okay. Suppose that the region D is projected on the x-axis in the interval from A to B, and it is bounded along the curve L first y is y first of x in this, and y is y second of x. Y first of x is less than or equal to y second of x. Then the area of a region Z is integral from a to b y second of x dx minus integral of a to b of y first of x dx. Okay. But the first integral is a line integral over the curve L2 mpn. Since y is y second of x, is the equation y integral of a to b, don't want to write down, y second of x dx equals integral over curve mpn pn of y dx. Okay. The second integral is a line integral of the curve L first mqn that it is integral from a to b of y first of x dx equals integral over mqn of y dx. By property 1 of the line integral, we have that integral m pn of 1 minute, please. I try. Of y dx equals minus integral of npm of y dx. Hence, S is minus integral of n p m of y dx minus integral of m q n of y dx equals minus integral over L of y dx. Formula 5. Where the curve L is traced in a counterclockwise direction, if part of the boundary L is the segment M first M parallel to the y-axis, then integral from m first to my dx will be equal to 0, and equation 5 holds true in this case as well. Now, similarly, it may be shown that S equals integral over L of x dy. Okay. Adding 5 and 6 term by term and dividing by 2, we get another formula for computing the area S. S is 1 over 2 integral over L x dy minus y dx. Formula 7. In this place we must end our lecture because our time ended, and we continue our class on the next classes. Goodbye, good luck,
Goodbye, teacher.
bye.
Thank you, teacher. Bye.
Goodbye, teacher.
Goodbye.
Have a nice
Goodbye.